Good morning, folks. My name is Zach Zapala, and I'm the founder and CEO of Particle. Welcome to Spectra Showcase. Spectra is an annual conference that we run with our customers and users, bringing together folks from all walks of life to share best practices, talk about some of the things we've learned, how to build great products, how to build new business models, and we typically announce all of our new products at the keynote presentation. But this year, we couldn't wait. We have too many good things in the works for 2024, and we couldn't save them for Spectra. So instead, we created Spectra Showcase as a way to do just a product launch and to get some of the things that we're working on out in front of you. Now, 2024 is a big year for Particle. This is the 10th anniversary of our initial product launch, and our platform has developed a ton over the last decade, starting from the very early days where we were really focused on making it as easy as possible to do software development for an IoT product. We have expanded the platform from initially focusing on edge computing and getting the thing online to expanding into connectivity and networking and data automation and all the ways that we can create value with data as it flows from devices to the cloud and back, and management and administration of massive fleets of IoT devices. And our infrastructure has become everything you need to build an IoT product from soup to nuts, other than the application which you would build yourself. So you can build the things that make your product distinct and unique, and you can rely on our infrastructure to power that product. These days, Particle serves companies from about as broad of a set of industries as you could imagine. We provide technology to monitor lobster boats off of the state of Maine so that the Maine Department of Marine Resources can ensure that folks are complying with environmental regulations. We provide access control systems to safes and vehicles and fitness centers so the right folks can enter and egress. We provide monitoring solutions for generators and smart energy devices and huge batteries across a range of companies that are trying to move on to the next energy economy. We provide monitoring services for industrial equipment, industrial cleaning products, everything that you might need to run a heavy industrial process. There's probably Particle in there somewhere. And a lot of it is hidden infrastructure, right? These are use cases that we didn't know existed. You don't stumble upon these kinds of things out in the world. On occasion, we have the opportunity to see firsthand our products out in the field. We were in the initial launch of Bird. We were powering the first set of dockless electric scooters that were deployed all over the world that you were tripping over on every street corner. And we were providing the technology to monitor their location and to lock and unlock them and to figure out the battery levels and to send fleets of people out to recharge them and collect them. These days, we find ourselves in Mamava. We're in safe and protected breastfeeding and pumping facilities that are in airports to ensure that mothers who are breastfeeding have a place to do that that's safe and secure. My particular favorite is that I stumbled upon our products in Scooter Pals in the Phoenix Zoo. So I was on a family trip and we found these amazing animal-shaped scooters that you can lock and unlock, and so you know where they are and you can control them, and that's done by Particle. It's very, very fun. It is incredible to see our product out in the world and to see what you all are doing with it. It is absolutely extraordinary and is my favorite part of the job. My second favorite part of the job is taking new, exciting technologies that are hard for folks to access and packaging them up in a way that all of a sudden makes them accessible to a whole new wave of people. We did this for the very first time with the Spark Core in 2014, where we took the ability to create a Wi-Fi connected product, which was at that time incredibly cumbersome and complicated, and we bundled it all together into a solution that just worked out of the box to make things way, way, way easier. And we did it again with the Electron in 2015, where we took cellular technologies, also even more esoteric and complicated from a technology perspective, from a business perspective, bundled it all together so you can build a cellular connected product. And I'm excited that we have the opportunity to do that again, which sounds like we're about to launch a new radio, and that is kind of true. We are announcing a new radio, but not just one. We're announcing a few different radios. And so before I get to that, I want to talk about the radios that we currently support. So our customers connect devices to the cloud using either Wi-Fi or cellular connections. Wi-Fi is great for products that are in a home or an office, and cellular is great for products that are not in those places or are in an environment where the IT infrastructure is challenging and you just want to have a direct connection to the cloud. They're both great and they both solve problems in different ways, but neither of them gets our customers to 100% connectivity. Most Wi-Fi devices have something less than 50% of devices connected because the end user is responsible for setting it up and connecting it to the network, and they often don't, and that creates a lot of fall off. Cellular devices do a lot better, 70, 75, 80, 85%. 85% is great if we can get the vast majority of devices connected. That would be a great outcome. Because cellular networks are not everywhere. And so you can never get to 100% because even though cellular is arguably the closest, there's always that last 15% where you have devices that are in locations that can't get access to a cellular network for whatever reason. A lot of our customers need 100% connectivity. The product has to work, which leads to the question, what if there was a radio that worked everywhere? Well, I'm excited to announce that Particle's about to, I'm just kidding. We do not have a radio that works everywhere. There is no radio that works everywhere. Radios are designed for specific applications. There are some that are best suited for high bandwidth use cases. There are some that are best for low power use cases. That you can trade off range or the radio frequencies that you're using. And there's no one solution that can work everywhere for everyone. But what we can do is we can combine radios into a single package that allows us to use different technologies in different environments so that you can have a product that works everywhere. And so the promotional materials for this announcement said something amazing is coming. Well, the M stands for multi-radio. I'm very excited to announce Particle's multi-radio platform that allows us to combine a bunch of different wireless radios into a single product that can work anywhere in the world in 3 different form factors: our SOM, our modules, which is called the MSOM, our development board called the Muon, and our gateway, Monitor 1. So before we talk about these products, let's talk about the radios that they support. So we'll start with the ones that we already know and love, Wi-Fi. So we all have Wi-Fi networks. We're all familiar with Wi-Fi networks. What Particle does is make it easy to create a Wi-Fi connected product. We provide a seamless setup experience so you can get things connected to the network very easily. We support dual band networks, so 2.4 gigahertz and 5 gigahertz modern Wi-Fi networks. We provide connectivity vitals so you can monitor the connection, make sure it's working the way you expect. We have security that your IT guy won't reject because insecure IoT devices on a network are the bane of every IT guy's existence. We make it easy to build Wi-Fi connected products. Now, cellular. We support 2 different parts of LTE. We have LTE-M devices, very low power, very low cost. We have LTE Cat 1 devices that are a little bit more bandwidth. They both work great in different parts of the world. Those parts of the world are starting to overlap more. We have EtherSIM for global connectivity, so we handle SIM cards and data plans. That's all integrated into the platform. You don't have to worry about any of that. And we provide It Just Works connectivity, which means these things just connect. And you don't have to know anything about how cellular networks work, about how to traverse those networks in order to make these things work reliably. A lot of that comes in the form of the software that we've built into our platform to make these things work. And some of it comes from the human beings behind the scenes. We have this group of people called Particle Watchdogs that are overseeing your fleet. And so they're watching for any issues that might happen because a tower went down or because a roaming connection between 2 different carriers broke. We identify those issues, we resolve them before you even notice them. We do all these things to make it easy to connect things to a cellular network. Now, let's get into the new radios, and I'm going to start by introducing satellite. So what is satellite networking? Well, there are these things that are up in the sky, and we use them to communicate. The satellite relays information from ground stations somewhere. So somewhere you've got a ground station that has a big satellite dish that's pointed up at satellites up in space, and those messages are then being relayed down to wherever these devices are. And those satellites can be geostationary, they can be low Earth orbit. There's a bunch of different satellite networks that you can connect to that have different properties. And these have been around for a while, right? Satellite is not new. It keeps getting better because there's more and more satellites that are being deployed. And so we have better solutions available to use this network. And we've been watching this for years, waiting for the moment where we thought satellite was ready for our customers. And we think we're finally there. Now, NTN is great for remote assets, things that are far away from a cell tower where you can't get any other mode of connectivity. So we're talking about the Permian Basin in Texas, where a lot of oil and gas operations, if you're monitoring methane emissions or the state of equipment, this is a great use case. If you're doing mining or forestry, or you're trying to monitor wildlife or national parks or anything where people are not there very often, where you can't get a reliable cellular network, NTN is great for that, especially because you need to have view of the sky. These are not things that work indoors. They're designed for devices that have a clear view of the sky so you can get a reliable connection to the satellite. In order to make this happen, we need a network operator. We need a partner who's got connectivity that goes through the satellite network in the same way that we work with telcos and carriers to provide connections through the terrestrial networks. And so we're excited to be partnering with Skylo, a new network operator specifically focused on connecting IoT devices to the NTN satellite network to bring this to you. And the way that we're working with them, we are going to be incorporating their network into our platform the same way that we have with cellular networks and our cellular products. And we're going to be doing a bunch of work on our communications protocol to squeeze out every byte, because satellite networks are expensive. And so the more work we do to optimize the communication protocol, the more we can get you a reliable satellite network as the lowest possible cost. And that's what really makes this work better than prior satellite networks, because these networks have been around for a while. They do work, but they're expensive. If you wanted to connect something with an Iridium network, you'd be looking at a $150 module with a subscription that's going to cost you $15 to $30 per device per month, and it's going to consume a ton of power. Whereas we are able to deliver that at a third of the hardware price, a fifth of the subscriptions price, and a fraction of the power consumption. So a much better solution for customers who are trying to use this technology. Speaking of low power, let's talk about our fourth radio, which is LoRaWAN. Now, before we get into LoRaWAN, I want to acknowledge this is probably the most requested feature at every one of our Spectras over the last 4 years, where I'm doing these presentations and we've got this chat on the right where people are starting to make guesses about what we're launching or things that they want us to launch, and it's LoRa. We're excited to finally be there and announcing LoRa, but in a very particular way where we think we can provide the most benefit to the ecosystem that's developed around this technology. Before I get into that, let's talk about what LoRa and LoRaWAN are, and specifically what they are in relation to LPWAN, low power wide area networks. So low power wide area networks are a bunch of different ways of trying to send communications over these wireless radios designed for long range and very low power. And some of those are part of the cellular spec. So we use LTE-M, for instance. There's also narrowband NB-IoT. There's Sigfox, which is another proprietary network. LoRaWAN is an open standard LPWAN technology that relies on a radio called LoRa. LoRa, which is short for long range, is a proprietary radio that is insanely good at sending messages for a very long distance. It's typically measured in miles. We've seen customers push it to dozens or hundreds of miles. It's absolutely incredible what you can do with this radio. It's a great radio, but then LoRaWAN adds this open standards communication layer on top of that that allows these devices to connect to LoRaWAN gateways. And that's really where this gets interesting, because there's this ecosystem that's developed of LoRaWAN network operators that can support both these public networks that are available in a way that's similar to carriers, and then there's private networks that you can deploy on your own, and federated networks that sort of sit somewhere in between. And so what's exciting about this is that means that this is a radio you can use where other radios can't go. So if you're looking at an environment like a basement or an elevator shaft where it's typically really challenging to get wireless radios, first off, the radio itself is very well designed to sort of penetrate through these spaces. But in addition, you can put the gateway nearby. And so you can trade out that incredible range for the ability to kind of penetrate into these buildings. And that makes it very well suited for site-wide networks. And so if you are managing a building or a warehouse or a farm or a solar facility, and you want to be able to install a wireless network so you can put sensors all over that site, LoRaWAN's about the easiest way to do that, because instead of having a bunch of Wi-Fi routers or whatever other technology you're going to use, you can install one LoRaWAN gateway for a couple $100 and easily cover any site of any size. Extraordinary technology. Now, in order to make this work out of the box the way that we like to do things, we are partnering with a number of the network operators that exist out in the world, doing something ranging from public fleets to federated fleets to private fleets. And we're going to start with Helium, which is a decentralized network. So Helium has a network of 350,000 hotspots that are deployed all over the world that have been stood up by individuals over the last few years. As a result, 80% of the US population has access to the Helium network. It is a very robust network with a ton of hotspots all around you. And what's great is you can then hop on that network in a way that's not that dissimilar from a cellular network. And by adding that to our portfolio of networks, you have something that's lower power, you have something that'll work in a slightly different set of spaces, and that adds network redundancy to the existing infrastructure. Next, The Things industry is a great solution for people who want to manage their own LoRaWAN network. They've become leaders in the LoRaWAN ecosystem. They have 1.5 million devices connected to their networks. And the Things stack has become a great solution if you want to buy off-the-shelf gateways and use your own network server. And then if you want a private solution, Comcast Machine Q has been operating since the early days of LoRaWAN. They have customers who have massive fleets of LoRaWAN gateways. And so they have delivered this at scale. And what's unique about Comcast is they're providing an SLA, they're providing tier 1 support, they're providing all of the services that you need to ensure that these networks are operating the way that you want to. In particular, they have folks who can go on site to do installations. So if you or your customers want to have somebody who's going to roll trucks and make sure that these things are going to be connected, you can rely on the Comcast team who can do that the same way that they would for Wi-Fi IT infrastructure. It's incredible. In addition, there are a ton of other network operators and radios that we can use. The actual radio that we've got in this product isn't just a LoRa radio, it's a sub-gigahertz radio, so it can be used with other kinds of networks, other protocols. And so what else can you do with this sub-gigahertz radio? You can do peer-to-peer connections, you can operate as a LoRa gateway, you can connect to the Sigfox network or a number of open standards or proprietary networks. We'd love to see what you're going to do with this once we get this product out into the world in a couple months. Now that we've gone through the 4 networks, you might be asking, how complicated is this going to be? Because these are all very different radios. They work on different communication protocols. Some of them are IP-based, some of them are not. In order to use all of these, you would typically require a ton of networking expertise to be able to traverse this incredible complexity. Now, what we want to do is abstract that, is to make it as simple as possible so you can write one line of code, particle.publish, and expect that the information that you're sending from the device is going to show up in the cloud regardless of what radio network is available. And so in order to provide that, we're building in multi-network redundancy. So what does that redundancy mean in practice? Well, many of our customers deploy their devices into uncertain environments. So you're going to ship a device and it's going to be set up somewhere and you don't quite know where, and you don't know exactly what network is going to be available. And what's great about these multi-radio products is it'll connect to whatever it's got. And when you have devices that have multiple networks, then you get this additional redundancy layer where you can set the preferences of which networks you want to use. And as those networks fail for whatever reason, then it will automatically fail over to the next available network. And so just to bring this to life, we have here the MSOM, which is currently connected to the Ethernet network. So it's connected over a wired connection. Now, if we remove the Ethernet cable, obviously it lost that network. It will immediately reconnect over the Wi-Fi network, which is the set of preferences that have been set here. And then if we unplug the Wi-Fi router, it'll immediately reconnect to the cellular network, showing this multiple series of network failovers, ensuring that a device can connect regardless of what environment that it's in. The M also stands for many different ways to use this thing. So we have 3 different form factors that we're going to be talking about. The first is the SOM, the MSOM. The second is our development board, the Muon. And then the third is our gateway monitor 1. So the MSOM is the heart of all of these products. It's a system on module, same form factor as the prior generation, the BSOM, that is just cellular. It has Wi-Fi connectivity, it has LTE, it has satellite. It has a very powerful processor on it. This is one of our 4th generation products, so it has a 200 megahertz processor with megabytes of RAM and flash. It can handle media, it can handle EdgeML models. It's extremely capable. It has ARM trust zone security, and it also has tracking built in. So these all have GPS, GNSS, so you can track their location. You can also get accurate location using location fusion, which combines that with cell tower triangulation and Wi-Fi geolocation to figure out where this thing is using a bunch of different radios. There are 3 different variations of the MSOM. We have the M404, which is Wi-Fi, LTE-M, and 2G fallback. Then we have the M524, which is Wi-Fi and LTE Cat 1. And then we have the M635. This is the triple radio solution that has Wi-Fi and LTE-M and 2G fallback and NTN satellite. Now, to make this a quad radio solution, we then move on to the Muon. So you take any one of those 3 MSOMs and we'll put them on a carrier board, and that's the Muon. So unlike our prior development boards where you had a development board form factor and a SOM form factor, and they are different. The Muon integrates those two into one design. And so we take an MSOM, we put it on a carrier board, which is about the size of a credit card, and you now have your development board, which is great for prototyping because all of the pins are exposed with headers and you can plug it in with USB. It works out of the box. We've got a quick connector to connect to that whole ecosystem of accessories, which is great. It's also designed to take expansion cards, which we'll come back to in a second, so we can add something that's kind of like an Arduino Shield or a Raspberry Pi with different sensors and peripherals. And it's a great path to production because since it has the SOM on board, this is a great reference design for an end product. So you can take this design, customize it, and then use that as the reference design for your own custom electronics. The expansion cards allow you to have an off-the-shelf circuit board that you can attach to the top of this that adds the necessary sensors or peripherals for your very particular use case. And so we're going to be making a bunch of these ourselves. We're also going to be working with partners to create other expansion cards, and we're going to be issuing a design challenge to the community to see what else you can build. You can also, of course, build your own. And so if you want to have your own complete product with as little effort as possible, if you design your expansion card and use that with the Muon, that's basically everything you need to ship a product. In fact, if you then take that and put it inside the Monitor 1 enclosure, now we can take the development board and turn it into a gateway. And so the Muon was designed to fit into Monitor 1. So we can take a waterproof, industrial grade, mountable to any surface gateway that's well designed for both wireless and wired sensors to be connected to this thing. You can design your own expansion card or use one of the off-the-shelf ones, and you have a full-featured industrial grade product that you can ship incredibly quickly. This is the fastest path that we've ever created from first prototype to production. And so we call this our stackable design, where we can take a SOM and put it on a development board and put that in a gateway, and now we have an extraordinarily fast path from prototype to production. If you want to try this stuff, the Muon is available today for pre-order. So if you go to store.particle.io, you can buy a Muon for as little as $49, promotional pricing for the pre-order. You can get yours in Q2 or Q3, depending on which one you get. Order now, they will go fast. And if you want to try the MSOM, if you are an existing customer or if you're ready to start developing a product and you want to try one of these as soon as possible, we are already sampling MSOMs and we have customers deploying on this now. So if you want an access to a sample, please contact our sales team. We'd be glad to get one in your hands and help you evaluate it. Finally, if you want to know more, if you want to come talk to us, meet us at Mobile World Congress. Next week is the largest event for the mobile and cellular world. It's in Barcelona. We'll be there. If you go to cal.com/z/MWC, we'll be setting up a day of half-hour office hours, and we'd love to hear from you about what you want to do with this and what we can do to support you on that. So that is it. This concludes our first Spectra showcase. We will have more coming this year. We'll be doing Spectra later in the year, as we always do, but we're also going to be doing another one of these in April because, as I mentioned, we have too much good stuff coming in 2024. We're just getting started, and we have too much to talk about in one event. So let's do this again in a couple months. Thanks for joining me.